Good evening, students. So this video we are going to start with another question, right? And this question has been quite an old doubt of students, right? Since the time when I was in BJMC, right? Many students have asked me about why exactly diabetic mothers, right, produce large for gestational age babies. That means, why do we get macrosomia in fetus of diabetic mothers, right? And it's a very interesting mechanism, right? If we understand it in a step-by-step manner, right, it will help us in understanding how various pathophysiological mechanisms interact in the body of mother and fetus, right? So let's try to understand it, right? So there are myriad of hormones which increase in pregnancy, yes, but when it comes to understanding large for gestational age babies in diabetic mothers, one hormone is of critical importance, and that hormone is HPL, human placental lactogen, right? HPL, right? And this HPL, right, if you followed my previous video, right, you will know that HPL will lead to serine phosphorylation of insulin receptors, right? It will lead to serine phosphorylation of insulin receptors. Right? Once the serine phosphorylation of insulin receptors happen, right, then after various steps, right, which involves PI3K downregulation, right, and AKT phosphorylation dysregulation, AKT phosphorylation will be downgraded, right? After all these steps, the GLUT4 translocation, the GLUT4 won't be translocated, right? And if the GLUT4 is not translocated, that means the cells, right, the GLUT4 won't be able to come over here, right? If the GLUT4 won't be able to come over here, then glucose won't get transported inside the cells, right? If glucose is not transported inside the cells, right, of course, the glucose level will increase, right? The glucose level will increase. Now, once this glucose level increases in maternal blood, right, of course, it will try to cross the placenta, right? Let's draw placenta over here. Right? It will cross the placenta through GLUT1 transporter. Now here is the catch. It will cross the placenta through GLUT1 transporters, and it's a kind of facilitated diffusion, right? GLUT1, right? GLUT1. And what kind of diffusion it is? Facilitated diffusion. Now facilitated diffusion means what? That it is directly dependent on the concentration gradient, right? Facilitated diffusion. That means it is directly proportional to your concentration gradient. Right? If you compare it to, say, other substrates which cross the placenta, right? If you compare it to, say, amino acids, right? Now, amino acid cross placenta through secondary active transport, right? It will go inside in exchange of a sodium coming outside, right? So this, it's a kind of active process, secondary active process. So it is tightly regulated, right? It is secondary active transport, right? So it is tightly regulated. But you don't see that kind of tight regulation over here. right? And even the transport of lipids, right? It depends on lipoprotein lipase, right? It is dependent on lipoprotein lipase, and even that is tightly regulated. So be it amino acids or be it lipids, everything which crosses the placenta is tightly regulated. But in case of glucose, we have got GLUT1 transporter, which works on the principle of facilitated diffusion. That means it is just transporting with the help of concentration gradient, right? Here we can say one thing, that nature compromises with the health of the mother, right, to create a concentration gradient so that glucose can be transported inside the fetus, right? Since glucose is following the concentration gradient, you have to increase the maternal glucose up to a level where this concentration gradient becomes significant so that glucose can be easily transported. So nature compromises with the health of the mother so that the fetus can get enough glucose for its survival, right? Now, once this glucose enters inside, right? So all this glucose has entered inside the cell because of concentration gradient, right? What it will lead to? Now the beta cells have to respond, right? So this thing will lead to beta cell hyperplasia, right? Beta cell hyperplasia. Of course, the fetus is new, the beta cells are young, so they respond and you get beta cell hyperplasia, right? Now, once you get beta cell hyperplasia, they are going to release lot of insulin, right? Insulin. Right? And now this insulin will act on your insulin receptors. Right? They will act on insulin receptors and they will increase the level of PI3K. Just the reverse of what is happening in mother, right? In mother, the PI3K is decreasing, but in fetus, the PI3K is actually increasing, right? This will increase your ATK phosphorylation. Just everything reverse of what is happening in mother. So what will happen if ATK phosphorylation increases, right? If AKT phosphorylation increases, right, then the GLUT4 translocation will increase, right? The GLUT4 translocation will increase. Now let's make a cell. Now suppose this is a cell and the GLUT4 translocation has increased. So you will have lot of GLUT4 channels over here and the glucose will enter inside, right? Now if glucose is entering inside, what it will lead to? It will lead to increased glycolysis, right? It will lead to increased glycogen synthesis, right? And what else? It will increase ATP, more ATP formation, right? Now, since the insulin has increased, right? This is very important. Now, since the insulin has increased, this insulin, apart from acting on insulin receptors, can also act on IGF-1 receptors, right? Insulin-like growth factor. It can act on IGF-1 and IGF-2, right? This can lead to the growth of liver and placenta, right? Liver and placenta, right? Apart from that, insulin can activate mTOR pathway, right? It can activate mTOR pathway. Now this mTOR pathway can lead to increased amino acid uptake. Since it leads to increased amino acid uptake, right? The mTOR pathway leads to increased amino acid uptake. It can lead to hepatomegaly and cardiomegaly. Right? What else the insulin can lead to, right? This insulin can act on adipose tissue, right? Let's draw some adipose tissue somewhere. This insulin can act on adipose tissue, and it can do fast upgradation in adipose tissue. It is going to upgrade the fast inside adipose tissue, right? Right? Now what fast upgradation inside adipose tissue means that it will going to convert your glucose into triglycerides, right? The glucose will get converted into triglycerides, right? In short form, I will write TG, right? And this triglyceride will start getting deposited, right? Where it will start getting deposited in your abdomen, and interscapular area. Right? When it starts getting deposited in the interscapular area, this is going to increase your one index, which we call ponderal index, right? Now what is ponderal index? Ponderal index takes the ratio of your shoulder to head, right? Since the head size has not increased, why the head size has not increased over here? Because the growth of brain is not insulin dependent. The brain growth depends mainly on hormones like thyroxine and cortisol, right? So the head is not that much enlarged, but the shoulders have enlarged, right? Because shoulders have enlarged and head is not enlarged, your ponderal index increases. Right? It is shoulder to head ratio, right? Now what complication this thing can lead to? Since the shoulders are that much enlarged, right? So during birth, during parturition, the shoulder might get stuck, right? And if this shoulder, if the shoulder gets stuck in the pelvic outlet, it can lead to a condition which we call shoulder dystocia, right? And birth injury, right? This thing can lead to shoulder dystocia. Right? So all these factors when combined, right, can lead to macrosomia, right? So let's try to sum it up, right? How exactly, right? this why in diabetic mothers we get macrosomia of the fetus, right? First of all, your HPL level increases, right? This HPL, as we discussed in our previous video, will lead to serine phosphorylation of insulin receptors, right? Your PI3K recruitment will go down, right? Apart from that, your AKT phosphorylation will go down. If AKT phosphorylation goes down, right, your GLUT4 translocation will go down. The glucose won't be able to enter the cells, so of course the glucose will increase, right? There are various other ways in which HPL can increase your blood glucose level, like 11 beta HSD. It stimulates that enzyme, it increases the level of cortisol, and that can increase your glucose, right? But the main catch is that in placenta you have got GLUT1 transporters for its transport. So it's a facilitated diffusion, right? It depends directly on the concentration gradient. It is not tightly regulated, right? So nature compromises with the health of the mother to make the blood glucose available to the fetus, right? So it creates insulin resistance in the mother, which increases the blood glucose. Since the blood glucose increases in mother, this creates a concentration gradient through which the glucose crosses the placenta. If we take the case of amino acids and lipids, both these are tightly regulated. Once the glucose enter, it causes the beta cell hyperplasia, right? Once the beta cell hyperplasia happens, we get more insulin, and this insulin creates all the effects, right? It is going to act on your insulin receptors, it will increase PI3K recruitment, it will increase AKT phosphorylation, right? So it will increase the recruitment of the GLUT4 transporters. So more glucose will enter inside the cell, more glycolysis will happen, more glycogen will be synthesized, more ATP will be synthesized. This insulin can also act on IGF-1 and IGF-2 receptors, right? So it can increase the size of liver and placenta. This insulin can also stimulate the mTOR pathway. So it can increase the amino acid uptake. It can lead to cardiomegaly and hepatomegaly. This insulin can also cause fast upgradation in the adipose tissue. Once the fast gets upgraded, the more glucose will be converted into triglycerides. This triglyceride will get deposited in abdomen and in shoulders, right? Since the shoulders have enlarged but the brain has not enlarged. Why brain has not enlarged? Because growth of brain depends on hormones like thyroxine and cortisol and not insulin, right? So since the shoulders have enlarged and brain has not enlarged, so your ponderal index will increase, right? That is the ratio of your shoulder size to your head size, and this can lead to shoulder dystocia during parturition, right? So hopefully this video has helped you in understanding the mechanism, the pathophysiology behind why exactly diabetic mothers give birth to large for gestational age babies or macrosomic infants, right? So wish you all the very best. Thank you.